Hello, let's continue our Sudoku adventure with Whose Nine Is It Anyway by Randall. Nice reference to Whose Line Is It Anyway? I don't think there's any nines in this puzzle, though. Oh, we have plenty of nines in this puzzle. Gotcha. All right, well, let's go over the rules. We have thermometers in the grid. So these are these circles with, we call those bulbs, with the rest, with a line attached to it. So from the bulb, as we move down the line, as we move away from the bulb, we have to strictly increase in value. So if this was a 2, this has to be bigger than 2. It could be a 3, 4, 5, 6. It just has to be bigger than 2. Let's say it's 4. This now has to be bigger than the 4. So it can't be 1, 2, 3, or 4. It would have to be a 5 or a 6. And then this would have to be even bigger. So this 6 wouldn't work just because there's nothing bigger than 6 here to put there. But that's how thermometers work. We also have killer cages in the grid. First of all, digits can't repeat in a cage. So these cells with the dotted lines around them, those are called the cages. The dotted lines are the cages. In any cage, even if there's no clue in the top left, you cannot repeat digits. So Sudoku would normally allow me to put a 1 here and a 1 here, but the killer cage disallows that. Additionally, if there is a clue in the top left, that is the sum of all of the digits in the cage. So these two sum to 9. So we could do, for example, 3, 6. 3 plus 6 is 9. That would be one way to fill that cage. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so there's only 2 ways to add to 9. There is 3, 6, and there's also 4, 5. That's it. In a 6 by 6 anyway. So we can take every 9 and just put 3, 4, 5, 6 in it. But I can do something additional, which is I can color them. I don't know if this is 3, 6, or 4, 5, but whatever it ends up being, I'm going to call that green. So this is the green way to add to 9. Now this cannot also be the green way to add to 9. Why is that? Well, green has 2 digits. But now we put 3 greens in this row. 3 greens in this row doesn't work. So you can think about it this way. If this was a 3, 6, we have a 3, 6 pair over here, making this have to be 4 or 5. And so this has to be the 4, 5 way of adding to 9. So they're opposite ways of adding to 9. And so it cannot be green, which means I'm going to make it purple. So this is the purple way of adding. So now this has to be green because of this column. And then now because of this row, this has to be purple, or because of this column. So these are the same way to add to 9 as each other. That's helpful. What else can we do? We do have these thermos. So this is a 4-length thermo. So if you want to pencil the thermos, this is my strategy for doing it. There's other ways. But I do 1, 2, 3, 4. I just count up the smallest possible digit until I reach the end. Now we know that the biggest possible digit is 6. And so what we can do is we can work backwards and say, well, this has 2 degrees of freedom, meaning that it can be up to 2 larger. So this could be 5 or 6. And so now we need each of these to be able to be 2 larger. So this can be 4 or 5. This can be 3 or 4. This can be 2 or 3. So this can't be bigger than 3. We can verify that by going 4, 5, 6. Now this has no value, right? Or we can verify this can't be a 3. 3, 2, 1. Now this has no value. So that penciling does work. This cannot be a 3, though. Look what happens if this is 3, 4. Look what happens to this purple cage. It ends up being 5, 6, which adds to 11, not 9. We need to include a 3 or a 4 and a 5 or a 6 in this purple cage. So, and if this is a 3, it forces this to be 4. So it cannot be 3 for that reason. We have the same thing going on here. So 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6. It's the same length. But again, this can't be 3 because 3, 4 would break the purple cage. Now, 5, 6 is interesting, but doesn't actually break anything. Because 5, 6 makes this a 3, 4, and therefore that would be a 5, 6. But, let's see. What am I missing? We have this thermo. I'm not going to pencil this thermo, but this does remove 6 from this cell and 1 from this cell. I'm going to need a 1 somewhere in here. I need a 1 in here. I need 1 and 2 in here. I need 1 and 2 in here, 1 and 2 in here, and 1 and 2 in here. What can I do with that? I'm not entirely sure. Also, the boxes need 1, 2. This is 1, 2, and then whatever the other green is. Whatever this green. Okay. Oh, that's interesting. Yeah. So let's talk about this column. we have both purple digits accounted for and one singular green digit accounted for, meaning that the last three cells are the 1 and the 2, which aren't accounted for at all in green and purple, plus the other green, the one that's not this one. Well, the one that's not this one is this one. So this digit here actually ends up in one of these two. One of these two is green, which means one of these two is green. So the consequence I saw in my head was that this cell here has to be 1 or 2. Because remember, this is a 1-2 green triple, right? And the green is this one. And it can't repeat in the box. So this has to be 1-2. And it's similar here. This is 1-2 because purple is, sorry, the green is in one of these two. This green is in one of these two. But also, by putting the green up here, remember, green is 3, 4, or 5, or 6. So this actually can't be green. It's 1 or 2. So this green is this green. So we have to match them up. This can't be a 2 because this can't be a 2. And then this can't be 5 or 6 because this, so they match up and become 3, 4. If this is 3, 4, this has to be the 5, 6. Remember, we have 1, 3, 4 and 1, 5, 6 within our greens and purples. So it's the same deal here. One of these two is this green. And so again, it has to be this 3, 4. It's not this one. We could also see that this already has 2 greens in the row, but whatever. So that's 3, 4. It's green. And we got this one too. But I'm noticing because, yeah, and so this is going to be the 3, 4 green. So this green is this green. So this is 3, 4. This is 5, 6. There was something I was going to say. There's something important. Yeah, this 3, 4 actually affects the rest of the thermo. This can't be a 3 because this is at least 3. And so now this can't be a 4. So it kind of propagates upwards. This can't be 3, this can't be 4. And now we get something. Something's going on there. Interesting. Since we know that green is the 3, 4, in fact, yeah, this 3, 4 ends up here. This 3, 4 ends up here. It's all the same green. This is just 1, 2, 3, 4. We can do the same with purple in the rows. Can we? Yeah, this is 1, 2 purple. So this purple ends up here. So this is the other 1, 2. That's actually really nice. Yeah, this purple ends up here. This is the other 1, 2. So that this box needs the other green. It's here. This is the 5, 6. Yeah, we can kind of just look at roping at this point for that. We need another 1, 2 in here along with this purple. Sure what to do with that. It's tempting to give them different color. Okay, let's actually do that. So green, we'll put orange, or we'll put blue with green. They both seem like cool colors to me. So we know this one's blue. We know the blue is one of these two. We know the blue is one of these two. This is the blue. This is the blue. And this is still the green 5, 6. So this is kind of what we know. So this 5, 6 then, this is the green 5, 6. This has to be the purple 5, 6. I'll make purple, I don't know if I can split up purple yet, but I could flash it. Let's flash this purple with a yellow. So we know that purple yellow goes here and here. And then this is, let's flash this with a red. So we know that this is purple red. We don't know if this is purple, or we don't know if this is yellow or red. But we know these two are the same. But again, we don't know if it's yellow or red. So we haven't connected these together yet. What do I do about that then? So we know this is red plus the other one too. It's a 1, 2 red triple. I think I'm making this more complicated than it needs to be. But it's fine. I am going to need the green 3, 4 in here, and I'm going to need another 1, 2. So this is only from 1, 2, 3, 4. Is it? I need the green. Sorry, I need a green and a purple. Wait. What am I missing here? Right, these are both, sorry, these are both the greens. Yeah, green and blue I split up. So I need the other purple, the non 5/6. Ah, where does the 5/6 purple go in this box? Because it can't repeat in the cage. So the 5/6 purple ends up here. This is our 5/6 purple. So this is our 5/6 purple, and this is a 3/4 purple. Okay. We have the 1/2 here. I could color the 1/2, but I don't think I need to. So this is the green 5/6. There we go. Yeah, I needed a green in this box. I need the purple 3/4 in this box along with the 1/2. Yeah, this is 1 2 3 4. That's what I said before, and I erased it because I wasn't sure it was right, but now I am sure it's right now. So this is gonna be the purple 3/4 along with a 1/2. So this 5/6 is not the green. So this is also the purple 5/6. So then this purple 5/6 has to go in this box somewhere. It's right here because it's not the green 5/6. So this is not 3/4. So this is the yellow. So let's just call this yellow, and it's 5/6. And then let's just call this one purple 3/4 instead of introducing the red. So all these purple 5/6s are actually yellow. There we go. Okay. I know I'm making a mess of the colors, but so what do we do from here? So I have a unique color for 3/4 and 5/6 paired up. I could color 1/2s, but I haven't figured out how to connect them together yet. So I don't think it's super useful. This is just 1 2 3 4 as well. This is very symmetric. I think this is going to break the symmetry. So is there anything with colors that I can continue to do? Green needs to end up in this box, and these aren't 5s. Yeah, the two greens look in. So green's in one of these two. I don't know which one. What over here? Ah, green's in one of these two. Say but I need the purple 3/4 in here. That's going to join our green. So this is actually green purple. 3 4 5 6. So this has to be the other one too. These are not 1 2. Wait, but I'd need another 1 2 in here. Hold on, that's not right. The purple. Oh, right. The purple ends up here then. Wait, does it? Yeah, I need. Okay, this can't be a 1 2 pair. There's a 1 2 here. Anyway, this is a blue 1 2 pair. Blue is not 1 2. So where's the other 1 2 go in this box? It goes over here with the green. So this is 1 2 5 6. So basically, there's a 1 2 here. There's a 1 2 here. Where does the purple go? Because the purple is not the 1 2 5 6, and it can't repeat in this column. So this is purple. Now we have to match up the 3/4 with the 4/5 and say purple has to be 4. And that's going to give us a lot of digits. So purple is 4, meaning blue is 3. If purple is 4, it has to add to 9 with yellow, and so that makes yellow 5. And then if that makes green the 6. Okay, so this is 4. It's purple. I feel like my colors are just a mess at this point. This 1 2 pair tells us this is 4, which is purple. These are not 4s. Yeah, 3 is our blue. This can't be a 6 because it's on a bulb, and so it's not green. So this is our green 6. And come on, this is our green 6. Clicking the wrong buttons. There we go. So this is a 4 as well. This is our purple 4. And this has to be 2 or 3 for about, oh, it can't be 3. So that's our 2, making that a 1. Looking at 3 and 2, that's 3 and 1. We get the 2 and the 1, the 2 and the 1, the 2 and the 1, 1, the 2, and we're done. Let's just fix the colors here. So these end up being the 3s. Okay, and I think we're good. We didn't color the 1 2s. All right. If I made a mistake with the coloring, then That's comment bait. I don't know if I did or not. 4 colors in here, 4 colors here, 4 colors here, 4 colors. I think I got all the colors. All right. Anyway, that was fun. That was a neat coloring exercise. I think probably there was a cleaner way to color this and get the results faster, but I muddled my way through it. So yeah, let me know how you did. If you enjoyed this, why don't leave a like, subscribe, and a kind comment below.